Welcome to Machine Learning APIs by Example. I'm going to teach you how you can use pre-trained APIs to access pre-trained models with a single REST API request. My name is Sara Robinson. You can find me on Twitter at srobtweets, and I'm a developer advocate on the Google Cloud Platform team. I focus on big data and machine learning. I'm based in New York. This is my first time in Poland. I'm super excited to be here. So before I get started, thank you. I want to talk about what machine learning is. So at a high level, machine learning is teaching computers to recognize patterns in the same way that our brains do. So over time, as machine learning models are given more examples and experience, they can improve. And with more data, they're able to generate better predictions. So it's really easy for a child to differentiate between a picture of a cat or a dog. But it's much, much more difficult to teach a computer to do the same thing. So let's pretend for a minute that we don't have any machine learning models. We don't have any deep neural networks. And let's try some human-powered image detection. So if we take these two images of an apple and an orange, and we were to write an algorithm to differentiate between these two, what are some things we might look for? You can shout it out. Color. I heard color. That's a good one. So if we looked for color, we could say, are the majority of the pixels in the image red? If so, it's an apple. Otherwise, it's an orange. And that would work pretty well in this example. But what if we had grayscale images? Then we'd have to start over again. What are some things we might look for now? Stem, texture. Those are all good ones. We could look at those different qualities, and that would take into account the grayscale images. But then, what if we got crazy and added a third fruit? What if we added a mango to the equation? Then we have to start all over again. So you get the idea. But these images are all pretty similar. They're all images of fruit. They're relatively circular. So the image classification should be a lot easier if we have two images that look nothing alike, right? So what if we have a picture of a dog and a mop? They have pretty much nothing in common. The mop is not living or breathing. It has no eyes, nose, or ears. It's actually kind of difficult. So here we have pictures of sheepdogs and mops, 4 of each. And it's actually kind of hard, even for the human eye, to be able to distinguish between the two. So the point I'm trying to make here is, what if we have photos of everything? We don't know exactly what photos our users in our application might upload. Might not just be photos of fruit or animals. We're probably going to have photos of all sorts of things. And in addition to photos, we might have other types of unstructured data. So we might have video, audio, or text. And on Google Cloud Platform, we have 2 ways to help you make sense of this unstructured data. So on the left-hand side, if you want to use custom data to build and train your own machine learning models from scratch, we have TensorFlow, which is an open source library to help you do that. And if you want to run your TensorFlow models on managed Google infrastructure, you can use Cloud Machine Learning Engine. What I want to focus on today is the right-hand side, and this is what I like to call friendly machine learning. So these are APIs that give you access to pre-trained models with a single REST API request. So I'm going to cover all of these APIs in this presentation. And I'll dive right in with the Vision API. The Vision API lets you do complex image detection with a simple REST API request. And before I get started, I want to talk about some companies that are using the Vision API in production. So the first one, the example on the left, is Disney. And they use the Vision API for a game that promoted their movie Pete's Dragon. And what the game did was, it was a scavenger hunt type game that sent users on a quest where they had to take a picture of a certain item, maybe a couch, or a computer, and if they took a picture of that item, the app would superimpose an image of Elliot the dragon on that photo. So they needed a way to verify, did the user's image match the clue that it was given? And the Vision API was a great fit for that. Realtor.com is a real estate listing service, and they use the Vision API's optical character recognition feature to extract text from an image. So when somebody is looking for houses and they use the Realtor.com app, they can take a picture of the for sale sign and then be immediately directed to the correct listing in the app. And Realtor.com is using the Vision API to extract the text from that picture and direct them to the relevant listing. So these are the core features of the Vision API. Label detection will tell you, what is this a picture of? Face detection will tell you, are there faces in the image? Where are the faces located? And what are the different emotions in those faces? Are they happy? Are they sad, angry, or surprised? OCR was the use case I mentioned before with Realtor.com. This can extract text from an image. It can tell you where the text is and what language that text is in. And then explicit content detection, pretty self-explanatory, will tell you, is this image appropriate or not? And this is really useful for pretty much any site that has a lot of user-generated content. So you can, instead of having somebody manually review the content, is it appropriate or not, you can send it to the API, and then you only have to review a subset of those images. Landmark detection will identify common landmarks, and logo detection can find company logos in an image. So to show you some of the JSON responses you get back from these endpoints, I want to look at face detection. This is a selfie I took with 2 of my teammates who are actually here at this conference. We took this last year in Petra in Jordan. And face detection returns an object for each face it finds in the image. The JSON response here we see is just for my face. So we can see that headwear likelihood returned very unlikely, which is true. I'm not wearing a hat in the picture, although both of my teammates are. And then joy likelihood returned very likely. I was excited. I was on vacation, taking selfies. And it also returns data on where different features are in your face. And then if we look at landmark detection, we can take this picture of a pretty common landmark. This is the Eiffel Tower, right? It's actually not the Eiffel Tower. It is the Paris Hotel and Casino in Las Vegas. And I wanted to see if the Vision API could spot the difference. And the answer was that it could. So it correctly identified this as the Paris Hotel and Casino. And you'll notice that MID in the response. The MID is an ID that maps to Google's knowledge graph. So if you want to get more information on this entity, you can send the ID to the knowledge graph API to get more data on the Paris Hotel and Casino. We get a bounding box of where this is found in the image, and then we also get the latitude, longitude coordinates for this landmark. We've got some additional features in the Vision API. One is crop hints, which will give you suggested crop dimensions for your photo. Web annotations will search the web for additional details on your image, and I'm going to get into that more on the next slide. And then document text annotations improves the OCR model for the API. So it's much easier for it to identify text in large blocks of text. So if you have an image of a menu or a business card, it can break your text down into paragraphs, words, and symbols. So I want to focus a little more on the web annotations endpoint. And to do that, I have this image of a car. It's not just any car. It's a car from the Harry Potter movies. I'm a big Harry Potter fan. And it's on display in a museum. So this is a car from the second movie. And I wanted to see what entities the web annotations endpoint was able to find. So the first one it found was that this was a Ford Anglia, which is indeed the correct model of the car. It also returned Art Science Museum, which is a museum in Singapore where this car is currently on display. And then finally, it was able to tell me that this is from Harry Potter. So the way that it does this is it finds similar images from across the web, and based on the context of the pages where those other images are found, it's able to extract these entities. We also get, in addition to the entities, the web annotations endpoint will give us additional details on the image. So we'll get all the URLs where this image has been found on the web. So this is really useful if you have an app where users are uploading images, and you want to make sure that this image is theirs, it's unique, it hasn't been seen before. You can use full matching images to guarantee that. Partial matching images, exactly what it sounds. It'll give you URLs of visually similar images. So this is kind of like a reverse image search. So we might see images of this car in another context. And then pages with matching images will just show you the URL where all the exact image matches were found. You can all try this in the browser with your own images. If you go to cloud.google.com/vision, you can try it out, see if it's right for your application before you start writing code. And in case you were wondering about our sheepdog versus mop example from before, this is what the API returned for the bottom right picture of the sheepdog. So it's 99% sure that it's a dog, and it's even 77% sure that it's a Commodore, which is the exact breed of dog that this is. It was able to identify this as a broom or a tool, and I won't show you the response for all of them, but the API was able to identify 3 out of 4 for each of these correctly, which is pretty good considering that this model wasn't trained specifically to identify pictures of sheepdogs and mops, and it was able to identify almost all of them correctly. So that was the Vision API. Next, I want to move into the Speech API, which exposes the functionality of OK Google to developers. So it lets you implement speech-to-text transcription in your applications in over 110 languages. One company using this API is Azar, and this is a chat application. They've connected over 15 billion matches so far, and they're using the speech API anytime an audio snippet is sent between people. They'll transcribe it with the speech API. And these APIs are really easy to combine with each other, so they're also using the translation API. Anytime two of the matches don't speak the same language, they'll transcribe it with the speech API and then use it through pipe it through the translate API to translate it into the host language. We recently launched a new feature of the speech API just a couple of weeks ago, speech timestamps. So if you specify this in your API request, instead of just getting the transcription, you'll also get the start and end time for each word in your transcription, which makes it really easy to search for text within your audio. So I'm going to go into a demo shortly of the API. Briefly, I'm going to explain how it works. So I wrote a bash script that's going to call the speech API. First, it'll make a recording using socks, which is just a command line utility for audio. Then we'll create an API request in a JSON file. We'll send it to the speech API, and then we'll receive the response back. So let's go to the demo. Cool. So the way that I'm going to call my script is just with bash request.sh. And it's going to ask me to record 5 seconds of audio. So I'm going to record something. Here we go. I am super excited to be in Krakow, Poland for Google Developer Days Europe. And I'm going to send that to the API. While I do that, this is what my request file looks like. It looks like it did a pretty good job. This is the transcription that I got, and it's 93% confident that it transcribed that correctly. I want to briefly talk about what the request file looks like. So here in our config, we just need to tell the API the encoding type of our audio. We're using FLAC here, the sample rate in hertz, the language code, which if you leave this out, will default to English. If you're transcribing in another language, you just need to specify the language code that you're using. You can optionally pass it some phrases. So if you've got some proper nouns that are specific to your application that the API may not recognize normally, you can give it hints of things to look for. We can also give it a parameter called max alternatives. So you notice here we got 3 possible transcriptions back. So you can use max alternatives to specify that. And then you can pass your content in either as a base64 encoded string or as the URL of an audio file stored in Google Cloud Storage. So that is how the speech API works. And I've got one more speech API demo I want to show you to highlight the timestamps feature. So here I've got a video of Ors talking about GCP's, Google Cloud Platform's pricing philosophy. And below the video, I have the transcription that the speech API gave back. Now what I can do with timestamps is I built a demo that we can search through the transcript, essentially. So if I click on this,
Google Cloud Platform delivers
we can skip to the exact point in our audio where this occurs. So if I go to another
70%
line, you get the idea. So the timestamps feature I'm really excited about because it makes it easy to search a large library of video content just using the transcription. So the way that I did this is I extracted the audio from the video and then sent that audio to the speech API. So, and I have more than one video here. So I've got a bunch of videos about cloud, Firebase. So let's say I want to search for all my videos that mention Firebase. I can do that here, and I can actually jump to the exact moment in the video where I see Firebase. This video is a screencast tutorial about Firebase hosting, and we can see all the points
Firebase hosting
that mention Firebase, which is pretty cool. In this video, we've only got one mention of Firebase. So if our job was to look through the video and find all the mentions of Firebase, chances are we might miss it. But with the speech API's timestamp feature, we're able to jump right to that point in the video.
Firebase real-time data.
So that's an example of the timestamps feature of the speech API. So with the speech API, you can transcribe audio. Once you've got that text transcription, the next thing you might want to do is extract more data from it. And that's where the natural language API comes into play. So with the natural language API, you can extract entities, sentiment, and syntax from your text. One company that's using it is Wootrick, and Wootrick is a customer feedback platform. So what they enable their customers to do is if you look at that box on the top right, their customers place these feedback forms in various places throughout their application, and they ask them, how is your experience on this specific page from 0 to 10? So they rate their experience, and then they have this open-ended feedback. And Wootrick's job is to help their customers make sense of this feedback. So it's pretty easy for them to make sense of the numbered feedback. But what's much more difficult is making sense of that open-ended text. And they're using all three methods of the natural language API to do this. So they're using entity and syntax annotation to extract the subjects and see how people are talking about different topics. And then they're using sentiment analysis just to gauge, did the numbered score of the person line up with the open-ended feedback that they gave. And so this enables them to do things like, say they have a high-priority customer that's angry about usability. So they can route that request really fast to the right person. And with the natural language API, they're able to route and respond to customer feedback in near real time, instead of having people manually go through each open-ended response. So now I want to talk about each of the three methods of the natural language API. The first one is extracting entities. Obviously, I have a Harry Potter example again. So I just took a sentence about J.K. Rowling from her Wikipedia page, and I wanted to see what entities the API found in this example. We got these 5 entities back. And then I wanted to look closely at the JSON response it gave for each one. So notice that these are 3 different ways of referring to J.K. Rowling. If you're wondering, the third one is a pen name she used for a different book series. That's a topic for another talk. But all of these map to the same entity. So they all point to her Wikipedia page. So it's able to normalize these different mentions of the same thing. So in our JSON response, we get back her name, the type of entity, she's a person, and then we get some additional metadata. We get that MID, which maps to her knowledge graph entity, and then we get the Wikipedia URL for her. Similarly, for British, it maps to the Wikipedia page for United Kingdom. So if instead this had said United Kingdom-born novelist, it would have mapped to the same entity ID. And we get a similar one for Harry Potter. And if you have entities in your text that don't have a Wikipedia page associated with them, the API will also be able to identify those. It just won't return anything for metadata. So if this instead had said my name, the metadata would be empty because I don't have a Wikipedia page yet, at least. The second thing we can do is analyze sentiment. So if I had, this might be something I might find on a restaurant review. The food was terrible, I will not be going back. If I was a manager of this restaurant, this is probably something I'd want to flag and maybe respond to, but chances are I don't want to go through all the reviews to do that. So I can use the sentiment analysis endpoint to get some data on the sentiment of this text, and it returns 2 values. The first is score, and score will tell us on a scale of -1 to 1, how negative or positive is this text. And then magnitude tells us, regardless of being positive or negative, how strong is the sentiment in this text. And this is a range from 0 to infinity, normalized to the length of the text. So since this is pretty short, we get a small number of 0.9. And then the last method of the API is analyzing syntax. So this gives us more linguistic details on the contents of our text. So here, if we have the sentence, the natural language API helps us understand text. The first thing we get is a dependency graph. So this is called a dependency parse tree, which tells us essentially how do the different words in the sentence relate to each other. This is one piece of data we get back. We also get the parse label, which tells us what's the role of each word in the sentence. So in this example, helps is the root verb, API is a nominal subject. So it tells us the role of each word. We also get part of speech. So it tells us is it an adjective, a verb, a pronoun. And then we get lemma, which is the canonical form of the verb. So in this case, we just have one for helps. The canonical form is help. And this is really useful if you're counting how many times a certain word appears in the context of your app. You probably don't want to count helps and help as 2 separate mentions. They're really just the same word. So you would use the canonical form here to do that. And finally, we get additional morphology details on our text. This is going to be a little bit different depending on which language you send to the API. So this is just a visualization of all the JSON you get back. You can actually create your own if you go to the natural language product page. There's a little try it demo in the browser, so you can enter your own text. I'll share a link at the end. You can enter your own text and generate these visualizations as well. So I want to show you a demo specifically focused on the syntax annotation endpoint of how you could actually use that in an application. So I've been running some natural language processing on tweets using the hashtag GDD Europe. And what I did is I wrote a little node script that calls the Twitter streaming API. And I'm just looking for tweets with that hashtag. So the streaming API won't give me all the tweets, but it'll give me a subset of tweets with GDD Europe in it. So I'm taking those tweets, and I take the text of them, and I send that through to the natural language API for processing. And then I store that in BigQuery. And BigQuery is Google Cloud Platform's big data as a service tool. So it lets you analyze really large data sets super fast. So let's switch to a demo. There we go. OK, so this is the BigQuery web UI. It lets me visualize my data stored in my BigQuery table directly in the browser. And here I have the schema. Let me make this a little bit bigger. I've got the schema for my table. So I'm storing the ID of each tweet, the text of each tweet when it was created, how many followers the user has, the hashtags as a JSON string, which I get from the Twitter API, the tokens, which is a giant JSON string returned from the natural language API, and then the score and magnitude. So we can preview this. Looks like we've collected about 840 tweets so far, which is really, really small for BigQuery. BigQuery is meant for lots of data, but this is just a demo. So we've got the text of the tweet, and we've got the hashtags, and we have this giant JSON string of the natural language API response. And we write all our BigQuery queries in SQL. So you may be wondering, how am I going to parse this giant JSON string with SQL? And the answer is that BigQuery has a feature called user-defined functions, which lets you write these custom JavaScript functions to parse different columns in your table. So here I want to find what adjectives people are using when they talk about GDD Europe. And I've written a function just to look for each token. And if the part of speech tag is adjective, I'm going to do a running count. So I'm running this query. And let's see the results. So it looks like pretty positive adjectives used about GDD Europe, which is good. So these are the most commonly used right now. And again, what's really cool about this is this ran this on all 840 of our tweets. And it ran really fast, 3.1 seconds. But it ran this custom function on all of the tweets in our table, which is pretty cool. I'll do one more query for you. I'm a big fan of emojis, so I wanted to see which emojis are people using most frequently when they talk about GDD Europe. So I'm looking at the token again. It looks like the laughing, crying is a popular one, clapping, Firebase. Overall, not too many, though. So maybe people should use more emojis in their tweets. But the goal of this demo was just to show you what you can do with the syntax annotation endpoint of the natural language API to do things like see how sentiment is around a particular topic. So that's the demo. We can go back to the slides now. So another thing you might want to do with text, in addition to analyze it or transcribe it, is translate it into many languages to support all the users in your application. The translation API lets you translate text in over 100 languages. Before we get into it, I want to look a little bit at Google Translate. So I'm a big fan of Google Translate. Anyone else here use it? Looks like most people. So I use it especially when I travel somewhere where English isn't the first language. I was on a trip to Japan last year, and I really wanted to order octopus. So I translated it, found out that the word was taco, which I was a little confused, but I was like, I'm going to go with this. So I showed it to the waiter at the restaurant, and I did get octopus back, so Google Translate success. But you probably want to do more with Google Translate than just translate the word for octopus. And the translation API essentially exposes all the functionality of Google Translate to developers. One company that's using the translation API is Airbnb. And they actually have 60% of the bookings are connecting people that use the app in different languages. And they're using the translation API not only to translate listings, but also reviews and conversations. And they found that using the translation API significantly improves a guest's likelihood to book. Here's a Python example of how you would call the translation API using the Google Cloud module for Python. And notice here that we just pass in the string of the text we'd like to translate and the target text language. We don't need to tell it the source language. The API can detect that for us. And if you also just want to use the API to detect the language of text, so if you've got users inputting text in a variety of languages, you can just use the detect language endpoint to do that. So we get our translation result, pretty straightforward. One improvement we made to the API a few months ago was an improvement to the model called neural machine translation. So the way that the model works before, with first-generation translation, is that it would take each word in your sentence and translate it word for word. So this is similar to what you might do If you were traveling, you had a dictionary with you, and you had a sentence you wanted to translate, and you did a lookup of each word. Now, the accuracy would be pretty good. You'd probably get your idea across, but it wouldn't be perfect. And what neural machine translation does is it takes the context of the surrounding words around each word in a sentence, and it's able to produce much higher quality translations. There's a great New York Times article about it if you want to learn more. It's available at this link, bit.ly/NYT-AI-awakening. And just to highlight the differences between the two models, I've got a Harry Potter example again. What I have here on the left, I know there's a lot of text on this slide, but I'll explain it, is the original Spanish translation. So Harry Potter was translated into over 70 languages, and they didn't use the translation API to do that. That probably wouldn't have worked very well. They had somebody translating the text for each one. So this is a paragraph from the original Spanish translation, and I've translated it into English using first-generation translation in the middle, and then the improved neural machine translation on the right. And I've just bolded some of the differences. So you can see these are small improvements, but they make a big difference in terms of the overall quality of the translation. So that is the translation API. And the last API I want to share with all of you is the Video Intelligence API. And this is our newest machine learning API on Google Cloud Platform. And what it lets you do is it lets you understand your video's entities at shot, frame, or video level. One company that's using it is Cantemo. They're a media asset management company. And so all of their users have tons and tons of video content that they're uploading into the system, and they're using the Video API to help their users better be able to search large libraries of video. The best way to see how the Video API works is through a demo. And so the demo I'm going to show you here is what I've got is the video of a Super Bowl commercial for Google Home. And I'm going to play the video. And you'll notice that it starts with a mountain pass, goes to a house, a city street, lots of scenes changing in the video. Now we see a dog. I won't play the whole thing, but you get the idea. There's lots of scene changes in the video. And if you were to manually transcribe what was happening, you'd have to watch the whole thing, write down what was happening in each scene, and then maybe store those tags in a database somewhere. And with the Video API, it essentially does all of that for you. So the JSON response tells you at a high level what's happening in this video, what is the video about, and then at a granular level, what's happening in each scene of the video. So if we look below this, we can see all the labels that the Video API returned. So for example, it knew there was a dog in the video, and it knew exactly when that dog appeared. It knew that it ended with birthday cake. And if we scroll down, we can see it identified even the type of dog that we had there. And it's also able to identify that mountain pass from the beginning scene. So that's pretty cool. And this is just one video. So chances are, if you want to analyze videos, you've probably got a lot of videos sitting around in storage buckets. And the Video API, with the JSON response you get back, it makes it really easy to search a large library of videos. So if you look here, I've got lots of videos. And let's say I'm a sports media company. And I've got lots of sports footage, and I want to create a highlight reel just of one specific type of content. So let's say I want to create a highlight reel of all my baseball clips in my videos. So without the Video API, I'd have to have somebody manually watching all the videos to find baseball. With the Video Intelligence API, this is pretty easy. So if I search for baseball here, we see that I get back not only which videos have baseball, but we can see all the scenes that have baseball in them. So this video is almost entirely about baseball. I really like this example here because we've got a long video, and there's only one tiny baseball clip in the video. So here we have the year in search video, which Google publishes at the end of every year, highlighting top searches. And if we skip here, we can see that baseball clip. It's actually when the Cubs won the World Series last year. I'm from Chicago, so I was pretty excited about that. But there's only one small baseball clip in this video. So if somebody's job was to scan it for that clip, the chances are they might miss it. It's only 1 or 2 seconds of the video. But with the Video API, it's really easy to make our library searchable. So I'll do one more search. I'm going to search for beach because it might be nice to be on a beach right now. It's a little cold today. It was a little rainy. So now we can't go to a beach, but we can search for all of our beach videos. It's the next best thing. So here we can find the beach clips in all of our videos, which is pretty cool. So something that used to take hours, now with the Video Intelligence API, you can do in seconds or minutes. Let's go back to the slides. So just briefly, I want to share how the demo works because it uses a couple of other Google Cloud Platform products as well. All of the videos are stored in a Google Cloud Storage bucket. And I've got a Cloud function listening on that bucket. So that Cloud function is triggered anytime a new video is added. It's going to make sure it's a video file, and then if it is, we will send it to the Video Intelligence API for processing. And the Video API lets you pass it in the request parameters the URL of a different cloud storage bucket where you'd like it to write the annotations to. So once it's done annotating the video, it's going to write all my annotations to a separate cloud storage bucket. My front end is a Node.js app that's running on Google App Engine, which is our platform as a service tool. And so the front end isn't calling the Video API directly. All it's doing is getting the video from one cloud storage bucket and then the associated metadata from another. This is what the response looks like for label detection. So here we have a video that has a scene of bird's eye view. And we get this locations data. So it's going to tell us the start and end time in microseconds that this label occurs in our video. And then if it occurred more than once, I'd have more than one object in my segment part of my response. And we also get a confidence score. How confident is it that it correctly labeled this scene of our video? So that's all I've got for the APIs. I encourage you to try them all out in the browser. So as I mentioned for the Vision API, I showed you how you can try that in the browser. You can actually do that for all of our machine learning APIs. You can use your own audio, text, video, try it out, see the API response. And then if you want to find the code for most of the demos that I showed you today, it's available in the 2 repos listed there. So I'll let you all get a picture of that slide real quick. And thank you. Thanks for having me.